Hello there, you fellow science enthusiasts. So, how do I know that? Well, basically, you are watching this video, so I assume you are a science enthusiast. And you might be wondering, what is this video all about? Well, let me answer that question. Today, we will be learning about the generation of electrical energy from nuclear reactor in 15 minutes. So my name is Mustafa Lutfi, and let's join me in explore all about the generation of electrical energy in a nuclear reactor. For your information, this topic is also one of the things that must be learned by Form 5 physics students of Malaysia. And to be specific, it is in Chapter 6, which is nuclear physics. And based on the DSKP document, we can see that the learning standard of 6.2.4 stated that students must be able to describe generation of electrical energy in nuclear reactor. So, in order to achieve this learning standard, I have separate or make it into several parts. And the first part is nuclear reaction, and then after that we will be looking at the overview of a nuclear reactor. Then we go to the process of electrical generation in a nuclear reactor. Okay, so the first part is the reaction that occurs in a nuclear reactor. So we must look from the fundamental part of it. We first look at nuclear fission. Nuclear fission is a process where an accelerated neutron hit a heavy atom such as uranium, and this uranium will then split into smaller atoms. For example, krypton and barium. And then this collision will produce three neutrons that where these three neutrons can also or might hit another uranium atom, and then the same process will occur. The uranium will split into two and produce three neutrons, and then this process will be repeated until all of the uranium atom in the nuclear reactor has all reacted. And as you can see, this chain reaction will produce a massive amount of energy, and this is where the energy comes from. And as you can see, this the reaction, the energy produced will be in the form of heat. So uh, this heat that is generated is how we harvest energy from nuclear reactor. So just now we talked about the nuclear reaction, or to be specific, the nuclear fission that occur in a nuclear power plant. And from that nuclear fission, chain reaction occurs that results in massive amount of energy generated. So now let's look at what is there at a nuclear power plant. This is an overview, a basic overview of a nuclear power plant. So we have three buildings, which is the first containment building, and then we have turbine building, and lastly the cooling tower. And in each building, there is a specific circuit. For example, in the containment building, we have primary circuit, and the second one we have the secondary circuit, and in the cooling tower we have tertiary circuit. So from the GIF here, you can see that all of these three circuits are not connected to each other. They are isolated, and there is a reason for that. And for your example, what is flowing in this all three circuits? Are they different? And let me answer that question. They are all have the same material or substance flowing in the circuit, and it is water, but they serve different purpose for each circuit. So without further ado, let's look at the first part of the nuclear power plant, which is in the containment building. Okay, so now let's look at what is inside the containment building. So as you can see, there is the steel pressure vessel, and inside it there is control rod, there is fuel element, pressurizer, steam generator, and the wall of the container building is made up of reinforced concrete in order to prevent any radiation from leak into the outside environment. Okay, so from the chain reaction that we have learned just now, we can see that the reaction is very fast or very aggressive. So how do we maintain, like, control the reaction so that there is no explosion that occurs? So that is the purpose of the control rod. It will absorb the excess amount of neutron that is being produced by the chain reaction. And also, in the steel pressure vessel, they will use water to not only absorb the heat from the chain reaction, but also to act as a moderator. So for your information, a moderator is a tool that is used to slow down the neutron. So for control rod, it is used to absorb entirely, but for moderator, it is to slow down the neutron so that it can be captured by the uranium atom. Why they want to slow down the neutron? So when a neutron is too fast, it is less chance to be captured by the uranium and cause nuclear fission to happen compared to slow neutron. So that is why moderator is used to slow down the neutron. And this moderator is usually made up of heavy water. Okay, so now let's look at this video where it will explain, I will explain what happened in the early phase of electric generation in the nuclear reactor. So as you can see, that green tube or cylinder is the reactor pressure vessel. And then, as you can see, there is lots of rod coming out of it. And this rod, or all of this rod, is called the fuel assemblies. Inside the fuel assemblies, or inside each fuel rod, there is what we call the fuel pellet. So this fuel pellet, we wait for the video. So this fuel pellet is what the uranium or the plutonium is, and each pellet will be stacked inside the metal rod, and in a vessel, reactor vessel, there is sometimes more than 200 rod available. So there is a lot of uranium inside the reactor. And then when it begins to operate, high pressurized water will be pumped into the reactor, and this water is very high temperature. It's almost 270 degrees Celsius. So how can it not be boiled? And that is what the pressurizer purpose. So this pressurizer will pressurize the water so that it will not boil even at 270 degrees Celsius. And then due to the chain reaction, the water will be heat up and pumped into the heat exchanger, and then this water will flow inside this metal tube. And as you can see just now, in the heat exchanger, there are lots of this metal tube. So when this hot water flows through the metal rod, it will heat up the water that is inside the heat exchanger. So as you can see, this water inside the metal rod is the water in the preliminary circuit, and then the water around the metal rod is the water for the secondary circuit. And when this water is heated up by the metal rod, it will produce steam, and this steam will then be used to to spin the turbine, and this will explain in the second part of the nuclear reactor. So now we are in the second part of the nuclear reactor, and after the steam has been generated from the first part, the steam will then be flow through a pipe into connected to a turbine, where this steam will make the turbine spin, and the turbine will be connected to an electromagnet where there is coil around it. And when an electromagnet spins inside coils, it will produce electricity, same like the dynamo on your bike. When you cycle, when the tire spin, the lamp will be light up. And what happened to the water in after they have what happened to the steam after they have passed through the turbine? So when the steam pass through the turbine to make it spin, it will go to the condenser, and this condenser will then change the steam back into water, and the cycle repeat itself. So how what makes the steam condense back into water? So that is the purpose of the third circuit. So the steam that is being condensed, and the steam that make the turbine spin is the secondary circuit, and the water being used to act as the condenser will be the third circuit. Okay, so now we are in the last part of the nuclear reactor, and as I mentioned just now, the steam need to be cooled down, need to be condensed back to become water, so that it can be recycled. So what is used as the condenser? So this is where the third circuit comes in. So the third circuit will absorb the heat from the steam so that it can be condensed and changed back into water. And this water from the third circuit will flow through the cooling tower. So after it has absorbed the heat from the steam, it will go into the cooling tower to be cooled down. And this is what inside the cooling tower. We have the cold water basin, air inlet where cold air will come through, fill media, and then we have spray nozzle. So that hot water, after being used to condense the steam, will be sprayed into the water basin, and it will also be mixed with the cold air. So this cold air, how can there be cold air inside the building? So we know that uh, hot water is less dense than cold hot hot air is less dense than cold air. So the hot air will float to the top, and the cold air will remain at the bottom. And during this process, some water, about 2% of the water will be evaporated. So in order to refill the water, they will suck from nearby river or ocean. So that is why most of the nuclear reactor or nuclear power plant, they are located nearby river or nearby the ocean. And that's all the three processes that uh, occur during the generation of electrical energy in a nuclear reactor. Before I end this video, I want to leave you guys to have a think. We have seen, we have known that this nuclear reactor can produce high amount of energy. So, is the usage of nuclear reactor the future of energy generation? Like, for now we have uh, the burning of fossil fuels, hydroelectric, and we can see that these types of traditional energy generation, they consume or they affect the environment harshly. For example, making a hydroelectric power plant, lots of the area around it will be submerged into water, and the burning of fossil fuel will of course emits carbon, but nuclear power plant, they does not require uh, that large amount of area compared to hydroelectric power plant, and it does not emit carbon emission. It does not produce carbon that can harm the environment. So, do you guys think that nuclear reactor is the future of energy generation, or is there several things that is still need to be considered uh, using nuclear reactor to generate electrical energy? So, with that question, I leave you all to think, and have a nice day, and hope we can meet again real soon. Bye bye. Thank you.